right. Yes, it is. Here we go. Oops. File limit. 1 second. All right, so this is lesson number 9 of the online grade 11 college math course with Mr. Horn. Welcome aboard. And so the way this lesson is typically done with me, it's a little bit of a kind of a guessing game to investigate kind of what information is necessary to know about triangles to guarantee that they're exactly the same as one another. And so how I do this in class is a little bit more interactive. So I'm going to give you the rundown of the idea of it so you can still have the sort of the idea of the experience in mind at the very least. So I would tell you, you know, in groups of 3 or 4, you're going to be asking questions. I say it in writing so that it's silent and no one gets to get the information other than the individual groups. And it's kind of like a contest, right? To see who can find out the information necessary to get the right triangle drawn the fastest. And so each group would have a ruler, and protractor, and pencil, and so on, right? And so the first groups that can write the triangle correctly win, whatever they win, right? So, you know, the groups start doing activity, and quite often they'll ask, you know, questions that they soon realize aren't super helpful. Like they'll ask, like, is that a right triangle? And if the answer is no, they know nothing about that triangle other than it doesn't have a 90 degree, right? Or they'll ask, is it an isosceles triangle? You're like, no. Or does it have 3 sides? And be like, yes. Anyways, those are all examples of questions that aren't very useful, right? Not too long into the process, some of the groups, you know, some of the members start to realize, like, okay, wait, we got to be more focused in how we ask. And so what comes out of that process is a group winning by asking a certain combination of information. And so Brooke and Noah and, you know, Liam and Ryan that year asked about an angle and a side and an angle in that order. And then they were able to draw the triangle. And then my cutout version of the triangle fit perfectly. And so they're like, yay, they got it. Another group, you know, would have asked about side, angle, side in that order. And, you know, if you draw the angle and then you draw sides particular lengths, you end up with the same triangle. It's just, it guarantees, it's enough information to guarantee that the 2 triangles are identical in every way. And then side, 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 a little harder to draw this one. To piece them together, it's easier if you sort of cut out sticks or strips of paper that are the length and you just put them corner to corner or at end to end or whatever and form a triangle. But yeah, so through that activity, the congruent triangle theorems, the minimum amounts of information you can have to guarantee congruence come out sort of naturally in what they decide to ask, right, to identify the triangle. And those are essentially the theorems that this lesson's about, right? And so if we're looking at this, you know, you talk about the side angle side theorem, side angle side would be like this, where you have, you know, this side and this side are the same if you fold that, and then the angle, fold that, and then this side is the same as this one. So obviously you could have this S1 and S1 and S2 S2 or something like that, but you know, just generically the idea of side angle side, whichever corner you have the angle, you have to set the sides each side of that angle, then that's enough to guarantee congruence. The angle side angle one that we saw, I talked about in the previous page. You know, if you had an angle here and then a side and then an angle, so right at that. So if you had an angle side angle, if you think about drawing that, you'd have a side length and then you draw particular angles. You have no control over where those things come together and intersect to make the other end of the triangle. And so it's not guaranteed congruence. And the other one was the side, side, side. And I mentioned it was a little harder to draw this, but if you had a length and another length, I'll try and do separate pieces here. A length, and a length. Put those pieces together. They're joined right now, but you get the idea that you'd go through here. You'd want to try and put them together so they form a triangle, right? You can tell, like, oh, I have to set it. Oops, I have to have that at a different angle in order to make this happen, and so on. And sometimes it's not possible. I'm actually showing you one where it's probably not possible unless maybe actually, right? Yeah, it's possible. This one. But it is possible to have it not be a triangle you could possibly make, right? But anyways, if you have the three lengths, you can guarantee that the same three lengths drawn in either group or wherever, it would guarantee congruence that they'd be the same. And notice we're talking about congruence in this, not similarity at this point. These are identical in every way, not just like proportional. We do that on purpose because the congruent stuff is much easier to do as an activity and check and ask questions and get answers and see that they're the same. Okay. There is also an angle side one, and that would guarantee congruence as well. It's a little harder to picture, so it's not usually mentioned as much in the Nelson textbook if you have one that you're using for the course. I don't need one because I'm getting all the questions anyways, but you can grab a grade 11 college textbook from your high school. If you have an Nelson, you'll see that they don't include this one either. So I'll just, right? But that is the congruence theorems. One that I want to show as well, so it'll link to something we see later on, is why not the angle side theorem or side angle theorem. And so that'd be like SSA or some other acronym that would make it LOL, right? Anyway, so angle side. If you picture angle side, that's not going to guarantee the same triangle because this side could have been swung over like that. Okay, so this is what's referred to as the ambiguous case, because this is an unknown length. It doesn't matter what length, right? So if you shorten this one down there, you have the same information. You have angle side and angle side, and they're not the same triangles. Okay, so this is referred to as the ambiguous case. And that's just meaning like ambiguity, and things are ambiguous. You can't tell between them. You can't distinguish them. So it's just using that same English language word for the triangles, right? So the question is, if you have angle side information, is there always more than one triangle possible? Well, the answer is no, there isn't always. So if this side was really long, right? The red one there is really long. It wouldn't be able to flip in and go in short, the small triangle version. If it's not long enough, then there's no triangle possible. So there certainly isn't two in that case. So it's just dangling in midair. This one, right? It doesn't have enough to reach. In the other cases, it might just reach perfectly and just touch in one spot only. Okay, so there's options, there's possibilities where you have one triangle, two versions where you have one triangle possible, and one version where there isn't a triangle possible at all. Okay, so generally we don't. It's just not included as a congruence theorem because of the complications. But what's going to happen is when we get into solving and working with triangles using sine and cosine law, you need to be aware of this because there's cases where you'll have two triangles possible, and the calculator will give you like the simplest one. I believe the calculator would give this version. And then you have to consider like, oh, it might be the other version of the ambiguous case. It sometimes comes up, right? And so going back to where we were just talking about similar triangles in the previous lesson. And so we kind of jumped to congruent because it's easier to talk about and ask questions and match triangles. There is a similar triangle version of this. So similar triangle theorems are, no pun intended, it's just the same word. They're quite similar to congruent triangle theorems. The only difference is when you're talking about sides, you're talking about equal ratios of corresponding sides, rather than the sides being like exactly the same length as one another. So all the sides are double or whatever, rather than all the sides are identical. Okay, so to put that in terms of similar triangle versions of this, pardon me, we have side angle side, just like before, except instead of the sides being equal, the sides are, pairs of corresponding sides that are in the same proportion. And of course, the included or the angle between them is the same. The angle similarity. Some people call it angle, but the third angle down here. It says the third angle right in here. It says the third angle is guaranteed, so it's kind of redundant to say the third A, because of the angles, it have to be the same. Because the first two would be whatever they are, and the third has to be whatever needs to be at a 180, of course. Anyway, so that one is essentially the same as angle side angle, right? Because instead of talking about the side where you have angle and then side that's known as for the other one and another angle, if you have those two angles, you're going to end up with the same shape, right? Because this side would be, half the size or something like that, and if you go with those same angles, right, they're both going to end up, coming to a point at the end of the triangle, and they're going to be the same shape. And then side will be the same as before, except we're talking about all three ratios of corresponding sides. Okay, so that's the idea of it. These are the triangles I'm going to use and cut it out. Make sure those are the right length. I'm teaching the classical person, I should say, and make sure those are the right scale of size when I do print it out. In case the new photocopier is different, and they would just I would just hold it against the page and show them images. Okay. So as always, the first page is the practice work for this to be submitted. Notice we're not doing a whole lot here other than just saying like what congruence here guarantees that you have congruent triangles. And so the symbols on here are saying like, okay, this angle is the same as that angle, and that angle is the same as that angle, and this side is the same as that side. And so you can tell we have angle, side, angle, congruence. So you could say then let's say triangle A, I'll do this one with you here. So triangle ABC would be congruent to, and I don't know if I made enough of an emphasis point about that. We're talking about congruence somewhere around here, right? We're talking about congruent triangles. The new symbol is equal sign, but it's more than just equals. It's because it's more than just one thing, right? So it's equals and even more. So we have that little squiggle above it, means congruent. So if we have triangle ABC, notice triangle ABC is like that. We're starting with, I think right now, to say how to do this, I guess you just flip it around, right? And I just want to make sure I get the right order here. We would say that's congruent to triangle, YZX or ZYX. Just because we don't have a number. Oh, I get it. Because I was going to say we don't have numbers, so it's messing me up. But we do have the symbols, right? And so if I were to use technology here to help illustrate what your thought process would be, is you'd have your triangle like that, and you see like, okay, if you just rotated it around, that wouldn't be the right sequence, right? So there's also like a flip involved with this one, but let's just make it simple here. I should just done this scratch right from start, but I got confused. So the A, B, C, we're starting at angle O. So we'll start at angle O, right? And go to the other angle, and then pinpoint it. So that's actually fine to do. If you're redrawing them, like we've done with similar triangles, you find you need to like flip the other triangle, and I'll show that in a bit. So the YZX would be the correct. Right, so be careful to have the right order in your letters when you're saying what triangles are similar. So notice here, in order to have the Y and then the Z and the X going from like O to whatever and so on, you'd have to like flip this thing like left, right, I think. Probably work if that did that right. Yeah, so now we have like paired up where it's O, O, angle O, and then side and check mark, right? And notice that it's ABC and YZX. Okay, you're redrawing. So there you go. I will leave that with you. Always message me, or I should say email me in the teacher file. That's probably the best. I have folders for each student, so I don't keep track of correspondence. I don't lose track of any message chains and so on. You need help with a specific question, maybe Teams, it might be better if you're good with it, but most people are just using D2L, so I think we'll just stick with that. All right, so that's it for now. See you later.